In this video, we will be looking at standard form of quadratic function. If you find this video helpful, share, like, and subscribe. So we're going to be looking at the properties of the graph of f of x is equal to ax squared plus bx plus c, which is also known as the standard form of quadratic functions. Now, if you're going to be looking at these two graphs in here, these are actually called the quadratic function graphs. One is opening up and one is opening down. So let's look at the characteristics and the properties of these parabolic graphs. Now, the parabola opens up, here it says up, when a is greater than 0 and opens down when a is less than 0. The graph is narrower than the graph of f of x is equal to x squared when the absolute value of a is greater than 1, and the graph is wider when a is less than 1. The axis of symmetry is x equal to negative b over 2a. Now, let's remember that the axis of symmetry is the one that cuts the parabola equally. So this is your axis of symmetry. This is, of course, our x, and this is our y. Then this is our parabola. So what we can see in here is this red line in here is actually called the axis of symmetry. And in this axis of symmetry, you also have what you call your vertex. Okay, your vertex in here, let's go back in here. The vertex here, the vertex is negative b over 2a and f of negative b over 2a. The y-intercept is c. So the point 0c is on the parabola. Okay, so let's look at what we have learned. So if you're going to be looking at this graph with the parabola going up, the equation of this is going to be y is equal to ax squared plus bx plus c. But in here, it's opening up because a is greater than 0. Okay, remember when a is greater than 0, it's going to open up. And you also have your axis of symmetry. The axis of symmetry is the one that's going to divide the parabola equally into two, and it's actually mirror. And on that same symmetric line, we call it the axis of symmetry, you can also find what you call your vertex. Now, to find the x coordinate of your vertex, you are going to use x is equal to negative b over 2a. And whatever comes out in this, you are going to substitute it in the equation in order for you to get the y coordinate of it. Now, let's look at this graph. This graph is really going down. Okay, it's opening down. But it's still also going to have the same ax squared plus bx plus c. But in here, the value of a, this value of a is actually less than 0. Okay, so this is going to open down. Okay, so another term that we can call here is actually called your concave down. You can say CCD, concave down. And the other one, the one opening up, is what you call concave up. Okay, so this is the focus of our study in this video this time. Okay, so let's give you an example. Number 1, graph f of x is equal to 3x squared minus 6x plus 1. Label the vertex, axis of symmetry. Okay, the first thing we're going to do here is to get the values of our a. Our a here is 3, the coefficient is 3. Okay, the b is going to be negative 6, and c is plus 1. That's going to be plus 1. Okay, so let's find first our vertex. The vertex is actually given by an x and y coordinate, but in order for us to find the x coordinate, we're going to use this formula, negative b over 2a. In this case, our value of b is negative 6. So don't be confused with this. That negative should still be appear in there, and then negative 6. Then 2 times our value of a is 3. So this is going to be 6 all over 6. Therefore, it's going to be 1. So there you go. That's the x-coordinate of our vertex. Now, in order for us to find the y-coordinate of that, we are going to use this value of y, and we're going to substitute it into this whole function, this one. Okay, so let's continue. That's going to be f of x. Remember, f of x is the same as your y. So this is going to be give you 3 times 1 square minus 6 times 1 plus 1. Okay, 1 square is still the same. 1 multiplied by 3 is going to give you 3. 6 times 1 is 6 plus 1. Here, negative 3 minus 6 is going to give you negative 3. Negative 3 plus 1 is going to give you negative 2. Okay, so the y-coordinate of our vertex is now going to be negative 2. Now, we said earlier, if you're going to be looking at what I said, that the axis of symmetry, this one, is going to be located at the x-intercept of our vertex, which is, if you're going to compute that, you're still going to use x is equal to negative b over 2a. Okay, number 1, graph f of x is equal to 3x squared minus 6x plus 1. Label the vertex axis of symmetry. First step we're going to do is to determine the values of our a, b, and c. Okay, the a here is this one. That's going to give you 3. Our b is negative 6. And c is equal to 1. So let's start looking at the vertex. Okay, here our vertex is actually should be located at x value and then some y value. Okay, here we go. So to find that, we're going to use this one. X is equal to negative b over 2a. This is gonna be giving us the x-coordinate, this one, the x-coordinate of our vertex. Okay, so my b here is going to be negative 6. So I'm going to retain the negative in here, and then multiplied by negative 6 divided by 2 times 3. So this is going to give me 6 all over 6, which is just 1. So this is now the x-coordinate of my vertex. So to find the y-coordinates of our vertex, we're going to use the same value of x, and we're going to substitute it in our function, this function. Okay, okay, so letter b, the second step, f of 1, okay, is equal to 3 times 1 square minus 6 times 1 plus 1. So this is going to give us negative 2. Okay, there you go. So our coordinate, y-coordinate is gonna be negative 2. So we're gonna write that one here. It's going to give you negative 2. Okay, let's give that also a little mark. So that's gonna be our vertex. Okay, letter C, we're going to find our axis of symmetry. Okay, the axis, we call it AOS, is actually you can find this using this equation, the same thing. X is equal to negative b over 2a. But since they are actually the same, you can just look at your vertex, and the axis of symmetry is actually at 1. Okay, so but let's just do it for the sake of learning today. So our value of b is going to be negative 6 over 2 times 3, and that's going to give you 6 all over 6, which is still 1. So if you're going to look at this one, your x-coordinate in here, in your vertex, and the axis of symmetry are actually the same. Okay, that's why if you once you have found or you have computed already the x-coordinate for your vertex using this formula, you can also now know what is the axis of symmetry. Okay, so let's graph our important parts in here. First is the vertex. Vertex is 1, negative 2. This is your 1, negative 2 here. So this is gonna be your vertex. And also they said that our line of axis of symmetry is going to be on 1. So we're going to just use a different color here. Okay, so this is going to be our axis of symmetry. Okay, it's gonna be red and broken line. So let's add one more point. Okay, example, I'm going to get the value of 2. Okay, remember your function f of 2 is equal to 3 times 2 square minus 6 times 2 plus 1. So that's going to give you 3 times 4 minus 12 plus 1. This is going to give you 12 minus 12. That's going to be 0 plus 1. So this is going to be cancelled out already. You're only left with 1. So my coordinates in here is going to be 2, 1. Okay, so why did I take this? Because I don't know where to go. So in here, 2 and 1. Okay, look at this one. 2, 1. This is my next coordinate in order for me to draw my parabola. Now remember this, because this red line, we call it your axis of symmetry, AOS, is going to cut your parabola into 2 equal parts. Then if I'm going to draw this one here, then where will I go? I'm just going to count how many units does this point from the center, and it's gonna only give me 1 point. So from here to that's only 1 unit. So I'm going to do the same thing on the other side, and it's going to mirror somewhere here. So in this case, it's now going to help me draw my parabola properly. So something like this. Okay, so if I'm going to go up and up, okay, this is now the graph of our function. Okay, number 2, graph y is equal to x squared plus 2x plus 1. Label the vertex and axis of symmetry. Okay, so first we're going to determine the values of our a, b, and c. My a here is only 1. My b here is equal to positive 2. And my c here is 1. Okay, let's find the vertex. Okay, by using this formula, x is equal to negative b over 2a. My vertex should be having x and a y. So here my value of b is 2. Negative multiplied by 2, 2 times 1. This is going to give you negative 2 over 2, which is just going to give you negative 1. So my x coordinate here is negative 1. Now we're going to find the y value of this. We're just going to use the negative 1 in here, the one that we have just computed, this one, and we're going to put it in our function here. Okay, so f of negative 1 is equal to negative 1 square plus 2 times negative 1 plus 1. So negative 1 square is going to give you only 1. Positive 2 times negative 1 is going to give you minus 2. And this is going to give you, so negative 1 minus 2 is negative 1. Negative 1 plus 1 is going to give you 0. So my y coordinate in here is going to give me 0. For the axis of symmetry, I told you earlier that your vertex is going to tell you what's going to be the axis of symmetry by looking at the x coordinate of that. Okay, and for this, our axis of symmetry is actually located at x is equal to negative 1. Okay, so let's graph our function. So first we're going to look at our vertex, which is located at negative 1, 0. Okay, where is my negative 1, 0? My negative 1, 0 is actually located in here. This is negative 1, 0. Okay, so this is our vertex. Now we're going to use a red line, and we're going to put our axis of symmetry, which is also negative 1. Okay, so let's just create a line in here. Okay, so this is our This one is going to be our axis of symmetry. So we don't know where to go, so we have to put one more point. Okay, so maybe let's choose from the vertex. Maybe I'm going to choose 1. What will happen if I'm going to put 1? Y also 1 is equal to 1 squared plus 2 times 1 plus 1. So that's going to give me 1 plus 2 plus 1, and that's going to give me 4. Okay, so my coordinates in here now is going to give me 1, 4. It means to say that if I'm going to have 1 in here, my next coordinate will be at 4. Okay, this is 1, 4. This is my next coordinate. That's going to be 1, 4. So since this is symmetric, so I can now start drawing my one side, this one. So I will count from the center. I'm going to count now to the point how many units. It's going to be 1 unit, 2 units. So this is going to give you 2 units. Okay. Now what will I do? I'm just going to count again from the center, the axis of symmetry. I'm going to count 2 units also here. And this is going to be my coordinates for my left side. Okay. So now I can now draw my parabola. So if I'm going to just extend that, okay, then this is now the graph of our function. Okay, so I hope you understand this very clearly. We're going to have more later. Okay, so let's look at the minimum and maximum values of a parabolic function. Okay, now we're going to go to the next part of our study, which is finding the maximum and the minimum values of a parabolic function. Now, because vertex, okay, the vertex is the highest or lowest point of the parabola. Remember this one, the y coordinate is the maximum or the minimum value of the function. Now, the vertex lies on the axis of symmetry, so the function is increasing. Here, let's write this one, increasing on one side of the axis of symmetry, and it's actually decreasing on the other side. Okay, so let's look at this one. If you're going to be looking at your parabola in here, we can say that the value of a here is greater than 0 because it opens up. Okay, we call it concave up, or another word for concave up, it's simply it opens upward. Okay, now if you're going to trace your function from left to right, okay, from here, you can actually see that the function is decreasing on one side, just like this one, it decreases, and once it reaches the vertex, from the vertex it's gonna increase again on the other side. Now remember this, that when your function graph is actually opening up, the vertex here, this is your vertex, it's actually on its minimum. That means that when I say minimum, the vertex is at the lowest point of it. Okay, so let's look at this other graph. Here we can say that when the a is going to be less than 0, then the graph is going to be opening down. Okay, another term that I introduced to you earlier is what you call your concave down. It's concave. Okay, let me just write that correctly. Concave down. Okay, the other one is called concave up. Let me just write that correctly. Concave up. Okay, going down to this concave down graph, okay, this is where you're going to see that the function is actually increasing on one side. That's the opposite of the other one earlier. So if you're going to be tracing your, if you're going to trace your function in here from the left on this side, it's actually increasing, and once it reaches its maximum, the vertex, it's now going to be decreasing again on the other side. Okay, so for the minimum, remember that the minimum value is the y coordinate of your vertex, this one. So f of negative b over 2a. The minimum is concave up, okay? That's the terminology I introduced to you earlier. Now, let's look at the domain. The domain will be all real numbers, but the range should be greater or equal to the y coordinate of your function. Okay, we're going to do that later after this one. It's going to be decreasing to the left of x equal to negative b over 2a. Now, if we're going to be looking at this one, don't get confused, because what I'm saying here is just going to be the x coordinate of your vertex. So just like this one, okay, on this one, it's actually decreasing on this side of this vertex, and that vertex actually represent your x is equal to negative b over 2a. And also, it's going to be increasing to the right side. Okay, here, if you're going to be looking at, this is your left side, this is your right side. Okay, so from the vertex, it's going to go up again in order for it to complete its concave up. Now for this, on the other side, the maximum value is going to be located at your y value, which is still f of negative b over 2a. Now, for clarity's sake, remember that this symbol is going to give you the y coordinates. So basically, your vertex has x and y, yeah? Okay, so when you say f of negative b over 2a, it's actually referring to this value of y. The maximum is concave down. I introduced that again to you today. I hope you're going to remember that. Concave down, aside from the keyword that we always use, which is open down, it opens down. Now, the domain is also all real numbers. And also the range is going to be lesser or equal to negative f of negative b over 2a, sorry. Okay, so remember again, for the sake of clarity, this one is actually talking about the y coordinate of your vertex. So let's see the increasing part. It's going to be increasing on the left side. So if you're going to be looking at the left side, here's your left side. It's going to be increasing, then it's going to reach its vertex, and then it's going to be decreasing on the other side. Find the minimum or maximum of f of x is equal to 1/2 x squared minus 2x minus 1. Describe the domain and range of the function and where the function is increasing and decreasing. So we're going to be looking at the minimum only, minimum or maximum, and then where the function is increasing and decreasing. Okay, so first step is we're going to determine the values of our a, b, and c. A is 1/2. B is equal to -2, and C is equal to -1. Now, let's look at our A here. Our A is greater than 0. It means that it's going to be concave up. And when it's going to be a concave up, then we're going to have the minimum value, okay? So we're going to have minimum in here. Next, we're going to find the x coordinate of our vertex. X is equal to -b over 2a. Okay, negative times -2 all over 2 times 1/2. Okay, this is gonna give you 2 only. I'm gonna cancel this one, so what is left is just 1, so it's just going to give me 2. Okay, so that is the x coordinate of our vertex, 2. Now we're going to find the y coordinate of our function. So we're going to get the same function, but this time we're going to evaluate it with the value of 2. So f of x is equal to 1/2. The value of x here is going to be 2 squared minus 2 times 2 minus 1. So that's going to give you 1/2 of 4 minus 4 and then minus 1. So 1/2 of 4 is 2. 2 minus 4 minus 1. So 2 minus 4 is going to give you -2, and then minus 1, it's going to give you -3. Okay, so this is the y coordinate of our vertex, which is -3. Okay, so now that we have our vertex, here is our vertex, to -3, it also follows that our axis of symmetry, okay, let me write it in different color. Our axis of symmetry is going to be located at x equal 2. Now let's answer what is being asked in this question. Find the minimum or maximum. We're going to describe the domain in the range, and then we're going to check where the function is increasing and decreasing. So let's use our vertex again. Look at our vertex. Our vertex is very important. So let's see, our domain in here is going to be all real numbers, yeah? And our range is now going to be the highest that we can find in our domain is only -3. It means to say that the values of our y should be greater or equal to -3. That's going to be our domain. Now let's just have a little sketch of the graph. Since the value of our a here, this one, the value of our a is greater than 0, then it means that our graph will be concave up. And when it's going to be concave up, then we're going to have the minimum value. So the shape is going to be just like this, okay? So the minimum is down here. Okay, so let's see. If you're going to be looking at the graph from the right side, on this side, this one, it's going to be decreasing. And when it's going to be reaching its vertex, then it's going to go up. Okay, so we're going to also describe where the function is increasing and decreasing. Okay, so now let's see. On the left side here, this is your left side and this is the right side of your function. On the left side, the function f is decreasing at, get your x value in your vertex. The x value of your vertex is 2. So it's going to be decreasing at x equals 2. At the same time, on the right side, the function is increasing at the same value. X is equal to 2. So that is the answer to this question. So we were able to find the domain, the range, and where the function is increasing and decreasing, also the minimum of the function. Okay, let's go for the next one. It's similar with the first one. Find the minimum or maximum of f of x is equal to 4x squared plus 16x minus 3. Describe the domain and range of the function and where the function is increasing and decreasing. Step 1, we're going to determine the values of a. A is 4, b is 16, and c is -3. Okay, so also what can we say about our a? Our a is greater than 0, then it means that it's going to be concave up. And if it is a concave up, then we're going to have again a minimum. Okay. Now let's find the vertex of the x coordinate of our vertex. Okay, so x is equal to -b over 2a. Our b is 16, -16 over 4 times 2. Okay, that's going to be, our a is 4 in here, okay? So that's going to be -16 over 8, and -16 divided by 8 is going to give you -2. Okay, so the vertex here, I'm going to write it here. My vertex, the x-coordinate of my vertex is -2. Now we're going to find the y-coordinate by evaluating this function by -2. So f of -2 is equal to 4 times -2 square plus 16 times -2 minus 3. So this is going to give you 4 times 4. Now this is negative and positive, so this is going to give you -32 minus 3. So this is going to give you 16 minus 32 minus 3. And if you're going to look at that once again, 16 minus 32 and then minus 3 is just going to give us -19. So the value of our y here is -19. Now we have our vertex. Okay, so we said earlier that the graph is going to be concave up because the value of our a here, the value of our a is greater than 0. Therefore, it's going to be concave up and it's going to have a minimum value. So it's going to be looking like this, okay? Something like that. And where you can find the vertex at the very lowest point. So let's answer. Is there a minimum? Yes, okay. F, say F has minimum at y is equal to negative 19 when x is equal to negative 2. Okay, when x is equal to negative 2. Next, the domain. The domain is going to be all real numbers. And the range, okay, the lowest that we can get in here, as the vertex is going to tell us, is going to be, it should be greater equal to negative 19. So y is going to be greater equal to negative 19 because it's going to be opening up. So let's say this is going to be your 19, negative 19 in there, and it's going to be going up to positive infinity. And last, where is the function increasing? So look at your graph on the left side. So remember, once again, don't forget to always look at your left side and your right side here. This is your left side and right side, okay? So if you're going to be looking at from the left side, the function f is decreasing. At which value of x? Decreasing at this one. X is equal to negative 2. While on the right side, f is increasing at x is equal to negative 2 also. Okay? So this is how we answer these kinds of questions. Okay, graphing quadratic functions using the x-intercepts. Okay? So here, when the graph of a quadratic function has at least one x-intercept, the function can be written in intercept form. F of x is a multiplied by x minus p times x minus q, where a is not equal to 0. Okay, the properties of f of x is equal to x minus p and x minus q. Okay, because f of p is equal to 0 and f of q is equal to 0, p and q are the x-intercept. Okay, these are the x-intercepts. So you're going to look at it from this graph. If you can see, the intercepts are actually the one touching the x-axis. Yeah, that's why they are called the x-intercepts. Okay, there are two of these. Okay, because they are in its factored form. This one, that's gonna be p and q, and these are numbers when we're going to be looking at some examples later. Now also, the axis of symmetry, this one, this is your AOS, or we call it the axis of symmetry, is going to be computed by this one. X is equal to p plus q divided by 2. Okay, so the axis of symmetry is halfway between P0 and Q0. So the axis of symmetry is already the average of these two. Okay, P plus Q, and then we divide it by 2. And then the parabola opens up when A is greater and opens down, okay, when A is less than 0. So earlier we have the same rule. So when A is greater than 0, okay, that's going to give you a concave up. Therefore, you're going to have a minimum value. It goes this way, okay? So the minimum value is down there. That's what you call your minimum value. While if you're going to have a graph that's going to be opening down, this is the case where A is less than 0. Therefore, it's going to be concave down, CCD. And the vertex is going to be at its maximum point. So just like this one. Okay, so I'm going to do this way. So you can see the vertex is actually at its max, see, and the graph is also concave down. This is what we mean by this opening up and down, and Letter A, the A in this function is going to be responsible for that opening up and down. Graph f of x is equal to negative 2 quantity x plus 3 times x minus 1. Label the x-intercepts, vertex, and axis of symmetry. So the first thing we're going to do is to, of course, we have to identify the x-intercepts, okay? The x-intercepts are this one, x, and then, okay, so in order for us to get the value of that, we're going to use the zero product property. So that's going to be x plus 3 is equal to 0. Therefore, x is equal to 3. Sorry, negative 3. And the other one is x minus 1 is equal to 0. Therefore, x is equal to 1. So the value of my p here on the first part is going to be negative 3. And my q is equal to 1. Now, why am I getting this? Because I need to know what are the coordinates of my vertex. Okay, so the next one you're going to do is to get the vertex coordinates. The vertex is located at x is equal to p plus q divided by 2. And that's going to give you, what's my p here? Negative 3 plus 1 divided by 2. This is going to give you negative 3 plus 1. Okay, it's going to give you negative 1. Okay. So let me write here. My vertex now has an x coordinate of 1. Now I'm going to find my y. And I can do actually that by putting this value into the equation. That's going to give you negative 1. Remember, this is our equation, okay? That's going to give you negative 2 times negative 1 plus 3 multiplied by negative 1 minus 1. Okay, so this is going to give you negative 2, negative 1 plus 3 is going to give you 2, and then multiplied by negative 1 minus 1 is going to give you negative 2. Now, if you're going to be negative 2 times negative 2, this is going to give us 8. Okay, so the y coordinate of my vertex is 8. So now I found my vertex. It is actually located at negative 1, 8. So now with all of this given information, now that we are able to compute, we're now going to graph our parabola. So the first thing is our vertex. Our vertex is located at negative 1, 8. Where is our negative 1, 8 in here? Okay, so our negative 1 and 8 in here is actually in here 1 and then 8. Oh, it's so high in here. It's going to be high as this one. So this is going to be our vertex. There you go. Okay, so our axis of symmetry is still going to be the same. That's going to be on negative 1. So let's use just this one. Okay, this part. Okay, so this red part is going to be your axis of symmetry, which is located at x is equal to negative 1. Now our vertex is actually located at, that's going to be negative 1 and then 8. Okay, now I cannot draw my parabola properly, so I need another point. So for this, I'm going to fill in, let's say, negative 3. I'm going to choose negative 3 here. What will happen if f of negative 3, that's going to give you negative 2 times negative 3 plus 3 times negative 3 minus 1. Sorry, negative 3 minus 1. Okay, that's going to give you negative 2. That's going to be 0. And this is going to give you negative 4. Okay, since everything is multiplied by 0, then that's going to give you 0 only. So my coordinates is going to be negative 3, 0. Okay, so where's my negative 3, 0? My negative 3, 0 is here. This one. So how many units from negative 3 to the axis of symmetry? That's going to be 1, 2. Okay, it means to say that it's going to give me also 1 and 2 on the other side, and that coordinate is actually amounting to 1 0. Remember, this is our coordinate for 3 0. Now I can now graph my parabola. Okay, so I'm going to start down here. There you go. And on the other side should be smooth. Okay, not perfect, but at least you can see what we are doing here. Okay, so this is how you're going to graph functions in using the x-intercepts. Okay, number 6, let's graph this function, negative x plus 1, x plus 5. Label the x-intercepts, vertex, and axis of symmetry. So let's find our P and Q in here, but before that, let's use our zero product property. X plus 1 is equal to 0, therefore x is equal to negative 1. Therefore, my P here is equal to negative 1. And the other one is x plus 5 is equal to 0. Therefore, x is equal to negative 5. So my Q here is equal to negative 5. Okay. Next, I'm going to get my x coordinate from my vertex, P plus Q divided by 2. So that's going to give you negative 1. Negative 1 plus minus 5 is still going to give me minus 5 over 2. And that's going to give me negative 6 over 2, which is going to give me negative 3. So my vertex x coordinate is 3. And if I'm going to put that in my function, that's going to give me negative times negative 3 plus 1 multiplied by negative 3 plus 5. So this is going to give me negative times, that's going to give me negative 2. This is going to give me negative, not negative, positive 2. Okay. So this is going to give me a total of 4. Okay. So this is now my vertex, negative 3, 4. So also, I would like to, using my vertex right now, I can now use my vertex to find my axis of symmetry, which is the x coordinate, which is x is equal to negative 3. What else? Since my a here, the value of my a in here is negative, it means to say that since a is less than 0, therefore it's going to be a concave down. It means to say it's going to be opening this way. It's going to be down. And if that's going to be the case, what will happen is that I'm going to have my maximum value. Maximum value because the vertex is on top. Okay, so let's start graphing this function. First, I would like to locate my vertex. My vertex is negative 3, 4. So it's going to be 1, 2, and 3. This is going to be my negative 3. And my 4 is 1, 2, 3, and 4. This is here. So the vertex in here. So let's label that. Vertex is going to be negative 3, 4. Now the axis of symmetry, we said earlier that it's going to be the x coordinate. So it's going to be concave down. Earlier I said because the a is less than 0. A is less than 0. So it's going to be concave down. It's going to be opening down. So this is our axis of symmetry. This is axis of symmetry, which is located at x is equal to negative 3. Now in this case, we don't have to add other more because we already have the intercepts, which is located at negative 1 and negative 5. So where's negative 1? So negative 1 is in here. Here's your negative 1. Oops, it's going to be negative 1. And it's negative 5. Okay, so this is going to be 1, 2, 3, 4, and 5. This is going to be, so if you're going to count from the middle, how many units are there? There's going to be 2 units, and from here to here again, that's going to be 2 units. So our graph is correct. So now let's try graphing our graph. So it's going to be like this. So it's not really very accurate, but at least you know what we are doing here. Okay, so this is how we graph this one. So the vertex intercepts. Okay, so we have to label our intercepts. Okay, our intercepts will be, this is going to be negative 1 0, and this is going to be negative 5. Oops, negative 5. Oops, again 0. Okay, so these are your intercepts. Okay, so this is how we're going to answer these kinds of practices in this lesson. I hope you have understood the lesson very carefully. Okay, here are practices for the following functions. State the vertex, axis of symmetry, minimum and maximum. Okay, let's look at the first one. First, let's determine our A. So my A here is going to be 6. My B is 0. And my C is equal to negative 1. Okay, negative 1. Okay, so X is equal to negative B over 2A. Our B is 0. So it's going to be 0 over 2 times 6. 0 divided by a number is going to become 0. So my vertex here is going to be at 0. Now, if that is the case, I'm going to say f of 0 is going to give you 6 times 0 squared minus 1. So that's just going to give you negative 1. So it's going to be negative 1. Okay, vertex has been found. The axis of symmetry. Now, remember that our axis of symmetry is the x-coordinate of our vertex. Therefore, the axis of symmetry, oops, before so doing that, say AOS is located at x is equal to 0. Now, the minimum and the maximum. So, since the value of A is greater than 1, then it's going to be a concave up. Okay, therefore, this function is going to have a minimum. Okay, so remember concave up. Here's your concave up. Your minimum, the vertex is actually at its lowest point. Okay, that's what we mean. So minimum at y is equal to negative 1 when x is equal to 0. Okay, and also we can say that there is no maximum. Also, we can say that it's going to be increasing, although it's not part of the instruction. We can say that the function is actually decreasing. Here, it's going to be decreasing at the value of x, which is 0. So let's write that one. So it's increasing at x is equal to 0, and also it's going to be decreasing at x is equal to 0. Next, number 2. Y is equal to negative 2x squared plus 8x plus 7. The first thing I recognize here is that my A is less than 0. There is a negative 2. Remember that negative 2 is less than 0. Therefore, what's my conclusion? It's going to be concave down. So it's going to be looking this way. Okay? So if that's going to be the case, then my vertex is actually at its maximum. So it's going to have a maximum. And then, what else? No minimum. Okay, so let's look at our ABC here. A is equal to negative 2. My B is equal to 8. And my C is equal to 7. The x-coordinate of our vertex is going to be negative B over 2A. Our B is negative 8. 2 times negative 2. That's going to give you negative 8 over negative 4. And 8 divided by 4, negative 8 divided by negative 4 is going to give you positive 2. So the vertex, the x-coordinate of my vertex is 2. Now I'm going to find my y. And that's going to give you f of 2 is equal to negative 2 times 2 squared plus 8 times 2 plus 7. This is going to give you negative 2 times 4. That's going to give you negative 8 plus 16 plus 7. So this is going to give you 15. Okay, so our coordinates in here is just going to be 15. So for my vertex, the y coordinate is going to be 15. So we're going to answer the other questions that's being asked of us. So since a is less than 0, then it's going to be concave down. Therefore, there is no minimum, but it has a maximum. So the maximum, look at your y value here. Okay, your maximum value is at y equals 15. Okay, and also we can say that the function is actually increasing. This one, look at this one from the left side. From the left side, the function is increasing. Okay, maybe I will just write, say f is increasing at x equal to, and on the right side, okay, f or the function is decreasing, DEC. This is INC, increasing, decreasing at x is equal to 2. Okay, next one. Here, g of x is equal to x plus 3 squared plus 5. This is not standard form. It's actually in vertex form. So if it is a vertex form, earlier in our lesson, we studied about our vertex form. Our vertex form, the vertex is actually located at h and k. This is our h and this is our k. And we also said that whatever we see in here, we're going to change the sign. Therefore, the vertex here is located at negative 3 and 5. Okay, this is not very easy. Using the vertex, then we can say that this is going to be positive. My a, since a is greater than 0, then it's going to be concave up. So it's just going to be doing this way. So my vertex is now at minimum. Vertex at minimum. Okay, so let's see. The instruction is vertex axis of symmetry. So we already found the vertex. The vertex is this one. The axis of symmetry, AOS, is located at x is equal to negative 3. Okay, the minimum. Do we have a minimum? Yes, because it's concave up. Therefore, the minimum is at y is equal to 5 when x is negative 3. We can also say that on the left side of the function, we can say that function is decreasing at x is equal to negative 3, and on the right side we can say that f is increasing at x is equal to negative 3. Okay, next. Okay, I've noticed again the negative in there. So when it's a negative, it means to say that my a is less than 0. Therefore, it's going to be concave down. And if it is a concave down, then I have a maximum value. Okay, so let's find the vertex. Because this is in its vertex form, this is our h and this is our k. We change the sign in here. So the vertex, the first one we're going to find is the vertex. That's going to be negative 2 and then 1. The axis of symmetry is the x coordinate of your vertex, which is x is equal to negative 2. Now, since my a is less than 0, that's going to be concave down. It means to say that it's going to be opening this way, okay, where the vertex is at its maximum. So there is no minimum, okay, but there is a maximum, max value at y is equal to 1 when x is negative 2. Also, we can say that on the left side, this is your left side and this is your right side. We can say that on the left side first. On the left side, the function is, okay, going up, it's going to be increasing inc at x is equal to -2. And on your right side, f is decreasing here. So if you're going to be looking at this part, this is now decreasing. This is the increasing part, and this is the decreasing part. Okay, so it's going to be decreasing at the same value, x is equal to -2. Okay, for the following functions, find the vertex, axis of symmetry, minimum or maximum, domain, range, and where the function is increasing and decreasing. Okay, number 5. Let's do number 5. My a here is equal to -4. My b is equal to 8. And my c is equal to 2. Now, what did I notice about my a? My a is less than 0. Therefore, that's going to be giving me a concave down graph. Okay, so if there's going to be a concave down graph, then I am going to have a maximum value. So let's check our vertex. X coordinate for our vertex is going to be -b over 2a. That's going to be -8 over 2 times -4. This is going to give you -8 over -8, which is just 1. So the first one I'm going to write is 1. Now I'm going to put f1 into the equation, which is -4 times 1 square plus 8 times 1 plus 2. This is still going to give you -4 plus 8 plus 2. And that's going to give you -4 plus 8, and then plus 2 is going to give you 6. Okay, here's my vertex already. Okay, the axis of symmetry is the x coordinate of my vertex, which is x is equal to 1. Okay, what else did they ask? The minimum. Okay, let's look at the minimum. Just looking at the vertex, we can actually find our minimum and maximum, the increasing and the decreasing part, using the x and y value alone. Okay, so in here we can say that since it is going to be, you still remember this one, when a is going to be less than 0, it's going to be concave down, and when it's going to be concave down, it's going to have the maximum value. So it's going to be looking like this, okay, something like that. Okay, the vertex is actually on top. So we can say in this, therefore, that there is no minimum, but it has a maximum. At what value? Look at your y. Y is equal to 6 when x is equal to -1. What else? Okay, the domain. We are asked to look at the domain. Here, the domain is going to be all real numbers. Okay, and the range. If you're going to look at the range, look at the 6 here. That is the highest number we can get, and it's going to be the values of y is going to be going down to -infinity in here. So we're going to say y is going to be lesser equal to 6. Okay, now increasing. Let's look at the left side of your function. The left side, ls, the f is, or the function is increasing. So it's going to be going up there until it's going to reach its vertex, and then on the other side it's going to be going down, say increasing at x is equal to 1. And on the right side, the function is actually decreasing at x is equal to 1. Okay, number 6. Let's look at this number 6. So my a here is going to be a is equal to 3. So if my a is equal to 3, that's going to be a greater than 0. Then it means that's going to be concave up. And if it is a concave up, then I'm going to have my minimum value. So next, my b is equal to -6, and my c is equal to 4. So let's look at our x coordinate for our vertex. Here, vertex. So that's going to give you -b over 2a That's negative times negative 6 all over 2 times 3. That's going to give you 6 divided by 6. It's going to give you 1. Okay. Then let's find the y coordinate. Let's put it in the equation. It's going to be 3 times 1 square minus 6 times 1 plus 4. Okay, this is just going to give you 3 minus 6 plus 4. And 3 minus 6 plus 4 is going to give you just simply 1. So our vertex is located at 1, 1. What else? The axis of symmetry is gonna be at x equal to 1. What else? Since we said earlier that our a is greater than 3, therefore we're not going to have any maximum value. Instead, we're going to have a minimum because our graph is going to be concave up, or it means it's going to be opening up. It's just like this way. Okay, so if you're going to see the vertex at its lowest possible location. So we're going to look at our minimum or maximum. We can say therefore that in this case, okay, we have no maximum. Maximum. Oh, sorry. Let's just rewrite that. No max, but it has a minimum value at y is equal to 1. Okay, what else? The domain. Let's look at the domain. The domain is going to be all real numbers. And the range, okay, since it is going up, and the lowest that we can get in here is going to be 1 until going up to its infinity. Okay, but we're not going to include infinity for now. Okay, so this is going to be y should be greater or equal 1. Okay, now the increasing on the right side, sorry, left side. Let's start with the left side all the time. Left side in this case, okay, if you're going to be tracing it going to x equal to 1, that's actually the function we say is decreasing. Okay, at x equals to 1, and on the right side the f is increasing at x equals 1. Okay, let's go for the next one. Y is equal to 3x squared plus 18x minus 5. My a here is going to be 3, my b is equal to 18, and my c is equal to negative 5. So here, let me just say again, a is greater than 0, therefore it's going to be concave up, and when it's going to be a concave up, then I'm going to have a minimum value of my function. X coordinate is going to be this one, positive, negative, yeah, we have to put negative. Okay, negative 18 over 2 times 3, and that's gonna give you negative 18 over 6. It's gonna give you negative 3. So the vertex starts at negative 3, then f of x, f of negative 3 is going to give you 3 times negative 3 square plus 18 times negative 3 minus 5. Okay, negative 3 squared is just going to give you 9. Okay, this is going to be positive, negative multiplied together. So 18 times negative 3 is going to give you negative 54. Okay, this is going to be negative 54 minus 5. So this is going to give you 27 minus 54 minus 5. And 27 minus 54 minus 5 is going to give you negative 32. Okay, so this is going to give you my y coordinate, which is negative 32. Okay, so now I found my vertex. That follows that my axis of symmetry is at x equal negative 3. Now remember this one, that our the value of a is greater than 0. It means that it's going to be concave up. It's going to be something like this. Okay, so I have my minimum value. So let's look at first our domain. Domain is all real numbers, And sorry, my range should be range R. If you're going to be looking at your lowest number that you can get in here for the range, it's going to be negative 32 and above. So y should be greater or equal to negative 32 because it's going up. So from 32 going up to the infinity. Now what else we say? On the left side of the function, f is decreasing again. Okay, it's gonna be decreasing at x is equal to negative 3. And on the right side, f is increasing at x is equal to negative 3, the same value of x. Okay, last, number 8. So in this case, what I'm going to do is to multiply. I'm going to distribute all of this to this, okay? So our function here is now going to give you 3 over 2x squared plus 18 divided by 2 is going to give you 9x, and then plus 6, okay? So here it's going to tell me that my a is going to give you 3 over 2, my b is equal to 9, and my c is equal to 6. Now what does my a tells me again? A is greater than 0, therefore it's going to be concave up, and if it is a concave up, I'm going to have my minimum value. Okay, so let's find our vertex. Okay, the vertex is x coordinate for the vertex, negative b over 2a. Okay, so that's gonna give you 9, or negative 9 I mean, 2 times 3 over 2. Okay, so I'm going to cancel these 2. What is left is just 3. Okay, so that's going to give you negative 9 over 3. It's gonna give you negative 3. So that's your x coordinate for your vertex. Sorry, vertex is going to be negative 3. Now let's find the y coordinate, which is f of negative 3 is going to give you 3 over 2 times negative 3 squared plus 9 times negative 3 plus 6. Okay, so this is going to give you 3 over 2 times 9. Okay, this is going to give you negatives. It's going to be negative 27 and then plus 6. Simplifying this further, this is going to give you 27 over 2 minus 27 plus 6. Okay, so here this is going to give me around negative 15 over 2, or it's also equal to negative 7.5. Okay, so this is my y coordinate here, negative 7.5. So now it's now going to follow that since I already have my vertex, then my axis of symmetry is also at x is equal to negative 3. Okay, what else? So since we have our concave up and our minimum in here, so our minimum is at, look at our negative 7. Okay, our minimum is going to be y should be greater or equal to negative 7.5. What else? So since it is concave up, it's gonna be like this. Okay, so on the left side, right side, on the left side the function is decreasing. Okay, I can also put this arrow at x is when x is at x equals negative 3, and on the right side f is increasing, okay, at x equals negative 3. Okay, what else? Our domain. Okay, our domain is going to be, okay, there's a little bit mistake that I made in here. I should not be putting minimum at greater equal to, that should not be. Okay, so the correct, let me just correct that one. it should be the minimum should be y is equal to negative 7.5. Okay, so that's going to be the answer to that for the minimum. Now the domain is of course all real numbers, and the range now here is going to be y should be greater or equal to negative 7.5. Okay, so I hope you understand this one. It's really a little bit very crowded here, but you can always review this video when you don't understand something. Okay, so this is all for this lesson about standard form of quadratic function. If you find this video helpful, like, share, and subscribe. Thank you very much.